Hey guys, so I'm unexpectedly out today, so you are going to be looking at some stuff today, and I'm making this video to hopefully help you out. So you need the template today from Canvas. You also are going to need Exploration 1.1 and 1.2. They're both green pieces of paper. If the sub has a paper copy for you, they'll give it to you. If not, you can grab an electronic copy off Canvas. Some of them might be put away, so I apologize. All right, we are starting with Exploration 1.1. So what I'd like you to do is go ahead and read through the example here and do number 1. After you've done number 1, I'd like you to make this graph in your, it says your grapher, it just means your calculator, and go ahead and plot the results there. So just make a sketch of what you see on your calculator. Please make sure that you are careful with the window. There shouldn't be anything that looks like an asymptote in your picture. So I'd like you to go ahead and pause, take care of those things right now, and then come back and let's see if your graph looks the way that it should. All right, so while you're checking, you should hopefully have something that makes sense that looks like this. So the number of degrees would be here, the time would be here, and the overall shape of the graph should be something that looks kind of something like this. Okay, then I want you to skip to number 4, and it says, at 1 second does the door appear to be opening or closing? How can you tell? Well, I think it's pretty obvious that about right here is where the door stops opening and starts closing again, because the graph goes from increasing to decreasing, right? So the number of degrees is increasing until this top point, and then it starts to decrease again. And so it matters where 1 second is, and it turns out 1 second is actually before that. So that would be approximately right here. So since the graph is still increasing at that point, you can see the slope at that point is positive, then I think it makes sense to say that it is still opening at that time. Okay, so the door is opening because the graph is increasing at t equals 1. All right, then in number 5, it says, what is the average rate at which the door is moving for the time interval from 1 to 1.1? Based on your answer, does this door seem to be opening or closing at t equals 1? So we're going to have an algebraic way to kind of say what we already said. All right, these are both times. So like this is the first time, and this is the second time. And when they say average rate, this is great because this is something that you already know, okay? So the average rate is actually just the slope between these 2 points. So we can use the same y2 minus y1 formula over x2 minus x1 that we have been using this whole time, okay? So kind of in general, it would look like this. We have to get the y values by putting those times into the function that we were given, okay? And so this is literally just what is the slope of this line. I do want you to keep at least 4 decimal places because we're going to be dividing by a really small time. Okay, so if I look here, it'd be d of 1.1 minus d of 1 over 1.1 minus 1. Okay, and those are things that you can just find in your calculator. You know what the function is, and so if you plug 1.1 in for t and 1 in for t, you can find the values on the top. Okay, and so it turns out to be like 102.6336 minus 100 all over 0.1, which works out to be, sorry for the back and forth there, we don't have motion sickness, 26.36. If I think about the labels, right, this is the change in the degrees over the change in time, and so the label here would be degrees per second. And since this is a positive number, right, we know that it is gaining degrees per second, therefore the door must be opening. Okay, because the average rate is positive. All right, now for number 6, it says find an estimate of the instantaneous rate. Okay, so instantaneous rate is different than average rate. Instantaneous rate means at a particular time. So literally at t, or at a, I wrote at twice, sorry, at a time. So not in a time interval, but literally at a time. So at t equals 1, what is it? As opposed to what is the average rate in this time interval around 1? Okay, so the deal is we can't calculate instantaneous rates using the slope formula, right? Because in the slope formula, there is no difference in time down here. The difference in time would just be 0, right? And so you obviously can't divide by 0. So what you could do is complete this average rate process a whole bunch of times where this time interval up here is getting smaller and smaller and smaller, or closer and closer to 1, okay? And then you can see what those slopes, right, your answers are getting closer and closer to, and that would be a way to estimate the instantaneous rate of change.